In 1974, the United States dumped more than 2 million tires into the Atlantic Ocean and called it an environmental victory. Off the coast of Fort Lauderdale, more than 100 boats followed a U.S. Navy vessel out to sea, carrying enormous bundles of tires. Overhead, the Goodyear blimp circled the site before dropping a single yellow-painted tire into the water, officially launching the Osborne Reef project, an ambitious attempt to create what was expected to become the world's largest artificial reef. But just a few years later, the bindings began to deteriorate. Hundreds of thousands of tires broke free from the seafloor, were swept away by storms, and repeatedly crashed into natural coral reefs, turning a celebrated green idea into an environmental crisis that has lasted for more than half a century. So what caused a project once praised as an environmental breakthrough to become a disaster costing more than $30 million US? Let's join Mandarin Tech and uncover the story in today's video. To understand why such a strange plan was ever approved, we have to go back to the United States in the early 1970s, when the country was facing a massive tire waste crisis. Every year, nearly 170 million new tires were being produced, while the number of discarded tires stockpiled across the country had already reached around 24 billion. They occupied enormous areas of landfill, collected standing water that became breeding grounds for mosquitoes, and when they caught fire, they could smolder for months, covering entire communities in toxic smoke. At the time, large-scale tire recycling technology barely existed. Meanwhile, Florida was experimenting with a completely different idea. Concrete blocks, pipes, and other discarded structures were being sunk offshore to create hard surfaces where corals, oysters, and fish could establish new habitats. The method worked, but it was expensive. Then came a calculation that seemed almost perfect. If tires were essentially free, extremely durable, and capable of providing surfaces for marine life to grow on, why not turn millions of tons of waste into an entirely new ecosystem? To turn that bold idea into a real structure on the seafloor, ocean engineering professor Ray Mallister, together with the Broward Artificial Reef Organization, selected a site off the coast of Fort Lauderdale, about 2,134 meters from shore. This would become the location where millions of tires were arranged into an artificial reef covering as much as 100,000 square meters, at depths of up to 21 meters below the ocean surface. The process began on land. Used tires were collected, stacked into clusters, and secured with steel clips. The tire bundles were then tied together with nylon rope and connected to heavy concrete blocks placed on the seafloor. Rather than dropping the tires individually, this system was expected to hold them in place as large structures, creating countless spaces where fish could hide and providing surfaces for corals and other marine organisms to attach and grow. From 1972 to 1974, the operation quickly expanded to an enormous scale. More than 100 private boats took part in transporting the tires, while the U.S. Navy vessel USS Thrush supported operations offshore. Thousands of Fort Lauderdale residents carried bundles of tires onto boats and transported them one after another to the dumping site. Goodyear supplied equipment and helped promote the project. The U.S. Army Corps of Engineers approved the permit, and local authorities directly supported the plan. Layer by layer, the tires gradually covered the seafloor. In theory, all they needed was time. Marine organisms would eventually cover the rubber, fish populations would gather in increasing numbers, and a massive field of waste would be transformed into a valuable new marine ecosystem. Just 2 years after the tires were placed on the seafloor, the steel clips began to corrode. In salt water, the metal was constantly exposed to dissolved oxygen, salinity, temperature changes, ocean currents, and marine organisms growing across its surface. Over time, the steel became thinner, lost its load-bearing strength, and eventually failed. This was a critical flaw because Osborne Reef was not built from heavy materials that could remain stable on their own. Each cluster of tires stayed in place only as long as the entire connection system remained intact. Once just a few fastening points failed, the load shifted onto the remaining connections, gradually destabilizing the entire bundle. As the steel clips corroded and the nylon ropes lost their strength, large numbers of tires began breaking away from their original positions. A structure designed to become a stable shelter for marine life was now turning into hundreds of thousands of loose objects scattered across the bottom of the Atlantic Ocean. Then hurricane season arrived. The tires could no longer remain still on the seafloor. They began to move. And that movement transformed Osborne Reef from a failed environmental project into a machine capable of destroying natural coral reefs. In calm seas, the tires might simply lie scattered across the sandy seafloor. But whenever strong currents arrived, especially during hurricane season, rubber tires weighing tens of kilograms began to roll, bounce, and sweep across the ocean floor. And right beside Osborne Reef were natural coral reefs that had taken decades, even centuries, to form. Each time the currents pushed the tires forward, they repeatedly slammed into, scraped across, and dragged over the coral. Thin coral branches snapped, larger colonies were scarred or crushed, while many organisms living beneath them were buried by sand and debris stirred up from the seafloor. A project originally intended to expand habitat for marine life was now directly destroying the very ecosystem it was supposed to support. By 1998, Hurricane Bonnie revealed just how far the tires could travel. Thousands were pushed away from the original site, while some reached the surface and were carried hundreds of kilometers by ocean currents. Eventually, tires from Osborne Reef even washed ashore on beaches in North Carolina, far beyond Florida. Then in 2005, the pressure intensified when 4 major hurricanes struck the region within just 4 months. Each storm carried the tires farther, expanded the affected area, and drove them into additional natural coral reefs. After decades beneath the Atlantic, Osborne Reef was no longer a fixed field of tires on the seafloor. It had become a mobile source of debris, continuously dispersed by hurricanes and ocean currents. A modern tire is not made of rubber alone. To withstand friction, heat, sunlight, and tens of thousands of kilometers of driving, manufacturers add a wide range of chemical compounds to the material. According to research, more than 120 potentially toxic substances have been identified in tires, including metals such as chromium, zinc, and lead, as well as numerous polycyclic aromatic hydrocarbons. One of the most concerning is 6-ppd-quinone. This compound forms when a widely used tire antioxidant reacts with ozone. By 2020, studies cited in the research showed that the chemical was particularly toxic to coho salmon. In the following years, detection methods continued to be developed for fish, shellfish, and marine mammals. Ironically, the very property that once made tires attractive for the project, their extreme durability, also made the consequences last much longer. They did not simply disappear after a few seasons underwater. Hundreds of thousands of tires remained buried in sand and sediment, exposed to seawater for decades. Osborne Reef ultimately failed in 2 different ways at the same time. When the tires moved, they became physical objects that damaged coral through repeated collisions and abrasion. When they remained stationary, they formed a massive concentration of artificial material embedded within the marine ecosystem. After nearly half a century, the seafloor there no longer resembles the artificial reef envisioned in 1974. Rubber rings now lie scattered among sediment, limestone, and the remains of damaged living structures. From dumping 2 million tires into the ocean to pulling them back out, Osborne Reef became the story of 2 completely opposite operations. In 2001, marine biologist Robin Sherman received a grant of about $30,000 to carry out one of the first major tire removal efforts at Osborne Reef. In the end, only 1,600 tires were recovered from the seafloor, at an average cost of roughly $17 per tire. It was a tiny number compared with the hundreds of thousands still lying below. By 2007, Florida had spent nearly $2 million and partnered with the U.S. Navy and Army, turning Osborne Reef into a real-world training site for military dive teams. Productivity increased dramatically. More than 10,000 tires were removed in the first year, 44,000 in the second, and as many as 73,000 in the third. But this highly effective phase did not last. Military units were later reassigned to other missions in Iraq and Afghanistan, as well as relief operations following the 2010 Haiti earthquake. The dive teams that had accelerated the cleanup never returned to Osborne Reef. By 2016, Florida had to turn to private contractors. A contract worth $4.3 million was awarded to international diving consultants. Over the next 3 years, the company recovered about 250,000 tires, but the cost had risen to nearly $28 per tire. The problem was that many tires had become buried beneath sand and sediment, trapped among underwater structures, or lodged close to areas containing living marine organisms. Every recovery operation required divers to locate the tire, free it from the seafloor, attach it to a lifting system, and then transport it back to shore. After years of cleanup efforts, more than 1 million tires still remained beneath the ocean. As the recovery campaign moved deeper into the reef, divers encountered an unexpected irony. Part of the failed project had finally begun doing exactly what it had originally been designed to do. After spending decades on the seafloor, some tires had become hard surfaces where corals and other marine organisms could attach and grow. Living structures gradually formed across the rubber, turning part of the discarded material into a genuine habitat for marine life. That meant divers could no longer simply attach cables and pull every tire to the surface. Doing so would also destroy coral colonies that had taken years to develop. Each tire now had to be inspected before removal, separating those that were merely waste from those that had already become substrates for living organisms. In one area, restoration teams carefully removed 747 coral fragments from the tires before relocating them to a healthier nearby reef. More than 89% of the transplanted corals were still alive after the first year. The tires had originally been dumped into the ocean to create marine habitat, yet when they broke free from their anchoring system, they ended up damaging natural reefs instead. But after several decades, some of those same tires had become places where marine life had settled. As a result, removing them could no longer be treated like an ordinary trash cleanup. It had to be carried out more like a delicate, underwater surgical operation. Coral reefs are among the slowest growing ecosystems in the ocean, with growth rates ranging from as little as 0.25 centimeters to 20.32 centimeters. For massive coral species, such as brain coral, reaching full maturity can take several decades. As a result, the Osborne Reef area may still need at least 20 years before it begins to show significant signs of recovery. And for a complete, multi-layered, naturally complex coral reef to form again, the process could take multiple generations. The challenge becomes even greater as ocean conditions continue to change. Rising sea temperatures, marine heat waves, and coral bleaching events are making natural recovery increasingly slower and more unpredictable. Back in 1974, Goodyear played a highly visible role in the campaign, but in the decades that followed, the company did not contribute to the Osborne Reef Cleanup Fund. Most of the financial burden instead fell on the state budget, federal support, the military, and organizations involved in the recovery effort. Florida alone spent $500,000 just to develop a plan for assessing the reef's recovery potential, before the cost of actual restoration work was even included. The failure of Osborne Reef does not mean that every artificial reef is a mistake. In fact, in many parts of the world, man-made structures placed on the seafloor have remained stable for decades and developed into habitats for marine life. Off the coast of Delaware, nearly 1,000 retired New York City subway cars were sunk to create artificial reefs. Their massive steel structures were large and heavy enough to remain in place despite strong waves and ocean currents. After unsuitable materials were removed, the hollow steel frames created countless openings and sheltered spaces for fish and bottom-dwelling organisms. These structures can support up to 400 times more food per square foot than the surrounding sandy seafloor. Gibraltar has also maintained artificial reefs since the 1970s, using concrete, vessels, and other massive structures. Their common characteristics are clear. They are heavy enough to resist being swept away, stable enough to survive for decades, and made from materials suitable for the marine environment. However, even when an artificial reef performs exactly as designed, that does not necessarily mean it creates more fish in the ocean. These structures may simply attract fish that were previously scattered across a wider area and concentrate them in one location, making them easier to catch without actually increasing the overall fish population. The 2 million tires were once seen as a solution to America's growing waste crisis, but corroded connections, powerful hurricanes, and decades of environmental exposure transformed them into a burden that would last for generations. The greatest lesson of Osborne Reef, therefore, is not really about the tires themselves. It is about what can happen when humans deploy an environmental solution on a massive scale before fully understanding its long-term consequences. So in your opinion, how thoroughly should large-scale environmental projects be tested before they are put into practice? Share your thoughts in the comments below, and don't forget to subscribe to Mandarin Tech as we continue exploring the extraordinary projects that are changing our world.